I'm going to move on to walleye and perch. Big changes with walleye in particular, particularly in Saginaw Bay. These two panels show on the top catches of age 0, so that's trawling done in the fall, after production in the spring, in the wild, and then catches of fish produced the year before, measured as yearlings. So very dramatic increases in natural reproduction of walleye in Saginaw Bay. Those percentage points in the first graph indicate how many, or what percentage of the fish that were captured were stocked. So as you can see, starting in 2003, the proportion of stocked fish started to decline, and stocking was actually stopped in Saginaw Bay. They had a plan in place. They met their targets. Didn't need to continue stocking walleye, so they stopped in 2007. And we continue to see very strong wild year classes with a very minimal, no stocked fish in those year classes. That's followed through to yearling production. So those fish survive when they're produced in strong year classes. We don't see exactly the same sort of dynamic on our side of the lake, and that's largely a reflection of the different walleye populations we have. A lot of our walleye stocks are associated with inflowing tributaries in eastern Georgian Bay and the North Channel. Historically, they are always much smaller populations. We certainly have seen signals from some of our populations of increases in walleye, and some sites we have the ability to do population estimates, and in Seventh Sound we've actually seen an increase in walleye abundance. So some positive signs similar to Saginaw Bay on our side of the lake. So following through with yellow perch, this is Saginaw Bay again. We've seen yellow perch production come up quite dramatically. These are, again, young of the year, so measured in the same year that they're naturally produced. Interesting thing with yellow perch, however, is that we haven't seen those fish survive. I don't include the diet data here for walleye, but we think that largely that lack of survival for yellow perch is because of walleye predation on young of the year and yearling yellow perch in Saginaw Bay. And again, that's kind of a reflection of the changes in the prey community. Historically, or when alewives were abundant, alewives served as the major prey item for walleye in Saginaw Bay. We have seen a surge in yellow perch on our side of the lake. This is a different data source. This is catch rates in the southern Lake Huron commercial fishery, but nonetheless, fairly strong signal of increasing perch abundance on our side of the lake. So it's quite a positive story with persids, walleye in particular. We've certainly seen walleye numbers come up, but as I mentioned, in some years the catches of walleye in the Michigan fishery are very abundant, in a numbers sense, surpass catch rates of other species in the past. Moving on to other species, I don't have a lot of detail here, but I did want to include it. Northern pike appear to be a species disadvantaged by what's happening with lake levels in Lake Huron. We've seen pike production, particularly in eastern Georgian Bay, decline quite dramatically as lake levels decline. That blue line indicates what's happening with lake levels. Pike spawn on emergent vegetation in the nearshore environment, and as you dewater those areas, you disadvantage pike. Bass, on the other hand, seem to be doing very well. This is Ontario data again from Seventh Sound. Bass production has been very strong since 2000. Bass are very abundant right now, and they're one of the species that are projected to be advantaged by climate change as temperatures warm. So we expect bass to continue to do well. One of the last presentations I wanted to get into before I summarize was some diet data that folks at U.S. Geological Survey have collected. This is from angler caught fish, and as I mentioned earlier, these are broad groupings of diet items in a number of species. During their study, this is 3 years worth of data. So this is lake trout on the left, a very strong benthic signal in their diet right now. That's largely round goby. That's Chinook salmon next, then steelhead and Atlantic salmon. So lake trout seem to have switched. That pelagic signal in Chinook diets is largely rainbow smelt. And steelhead, interestingly, had a very strong signal of insects in their diet. I've seen samples from individual fish where they have hundreds of actually land-borne insects in their gut. So they're actually feeding on insects blown onto the surface of the lake that have washed offshore.
And just in case you don't understand, benthic means the bottom of the lake, pelagic is
Up in the water column. So, any questions before I move on to summarize things? We've thrown a lot of information at you folks, so hopefully it hasn't been too confusing. Go ahead.
I just got one on the smallmouth bass. Not a lot of bass fishermen here, but I am.
Right.
Lake Erie has totally changed in the bass fishing. They've changed from crayfish to baitfish to whatever to goby fish like crazy. There's guys down there that guide, and they said it's unbelievable the changes they've made with the smallmouth bass. And they also said the same thing with the lake trout down there. When they're fishing for the smallies out in shoals that top off at 50, 60 feet of water, they're actually getting the smallmouth and the lake trout, and they're both full of gobies, like just gorged with them.
We've certainly seen that. You know, that diet data shows that fairly clearly with lake trout, that ground gobies are now a fair chunk of their diet. So, you know, seem to have that ability to switch prey species, and now gobies are a fair chunk of their diet. You know, there's still lots of uncertainty around the ultimate impact as ground gobies have colonized the Great Lakes. You know, there's a lot of concern around egg consumption, because they do that. They eat eggs on spawning shoals. You know, in Lake Erie, or amongst all of the Great Lakes where ground goby densities are highest, that's where they have the most concern, you know, particularly around bass production. What's going to happen to bass production with all these round gobies, really, really high densities? No real indication of changes in bass production in Erie as far as I'm aware.
Same with walleye.
Yeah, and same with walleye. If anything, bass, as you mentioned, has switched their diet to gobies. So there might be some interplay there that we don't quite understand yet.
I know some of the guys are getting 9-inch gobies, like that long on tubes when they're fishing for bass. Like they're huge.
Question in the back?
Yeah, well, not a question. Wasn't there previous studies that did show there was a correlation between population size of pickerel and perch? If the pickerel population went up, the perch went down, and then sometime perch got their...
In some systems, that relationship's that tight, like that strong, that as walleye numbers change, perch numbers change.
Yeah.
In other lakes, the relationship doesn't quite operate, you know, as strongly as that. You know, we've certainly, at least in Saginaw Bay, seen that dynamic operate because we have a prey community that has changed, and you know, it's not as, the prey fish just aren't nearly as abundant as they used to be without alewives. So all of those wild walleye need something to eat, and young of the year and the yearling perch are, you know, they always were in their diet, but now they factor very heavily in their diet in Saginaw Bay in particular. In the back?
One thing you were talking about, the predatory, or all the bait fish that's out there, there seems to be a huge reoccurrence now of emerald shiners.
Yeah.
And like, were they always in the lake? As like, you go to Goderich and that, there's like unbelievable amounts. Along the harbor and Soggy River to mouth.
Emeralds have always been a portion of the prey community in the lake. We certainly, you know, we didn't include that here, but one of the people involved in the presentations wrote a paper on that recovery. We certainly have seen a recovery in emerald shiner numbers. Their production does fluctuate from year to year fairly dramatically, but on average, yes, we certainly have seen a huge upsurge in emerald production after alewives declined again. The other species that's notable is gizzard shad. we've certainly seen an increase in gizzard shad abundance after alewives collapsed as well. All right, I'll move on to a summary. So, just to kind of conclude and try and look forward, it's pretty clear that ligotrophication, that's a scientific term for becoming less productive, more sterile. Seems quite clearly from the lower trophic data that I presented, that we summarized for our State of the Lake report, that that's occurring in Lake Huron. It's actually getting less productive, at least in the open waters, which is the portion of the food web that we're most interested in, because that's where fish get produced. Productivity overall seems to have declined in the open waters. We have had some good questions from people. Well, I thought it was a basic law of physics that you can't create or destroy energy. That's true. So you kind of have to qualify that statement. That energy hasn't actually disappeared. It just now goes into muscle production rather than in fish production. So decreased productivity largely applies to the open waters of the lake. So that leads into that term benthification. We've seen energy moving into the bottom of the lake, the quote-unquote benthic portions of the lake, and our lower trophic levels, the portions of the food web that produce fish, that grow fish, feed fish, are dominated by invasive species. We do have low invasive prey biomass right now. That reflects the collapse in alewives. Our demersal prey, so prey in the open waters, but near the bottom of the lake, surveyed by that bottom trawl, are now dominated by native species largely, but we've got low abundance. I didn't include our diversity talk, for the sake of timeliness tonight, but it doesn't appear that overall species biodiversity in the lake has changed. We do overall, in a general sense, seem like we've changed from a fish community as a whole that was dominated by introduced species to one that's more strongly represented by native species. And we've got widespread natural reproduction, both amongst native species, i.e. lake trout and walleye, and non-native species like Chinook salmon and steelhead in particular. We've got strong walleye and perch ear classes. Walleye of note because they're surviving and are contributing to the fishery. One of the things that we did want to kind of zero in on, we use this kind of as an analogy for a food web. I don't wanted to convey this as a result. We didn't actually include this in our State of the Lake presentation, but we wanted to show it tonight. This is just an analogy of how food webs work. We've talked about biomass. Although you may not see them, these are often